In everyday life, work means effort, but in physics, it's more specific. Work only happens when a force moves an object in the same direction as the force. This formula is simple. Work equals force times distance times cosine theta. If you push a wall and it doesn't move, that's zero work, even if your arms are shaking. But if you lift a box off the ground, that's real work, because your force made it move. Work is measured in joules, and 1 joule is the work done when you use 1 newton of force to move something 1 meter. Now, what lets you do the work in the first place? That's energy, the ability to do work. There are 2 main kinds, potential energy and kinetic energy. Potential energy is stored energy, like a stretched rubber band or water held up behind a dam. Kinetic energy, on the other hand, is the energy of motion, like a flying arrow or a speeding car. If you lift an object, you give it potential energy. When you drop it, that energy turns into kinetic energy as it falls. Energy constantly changes form, chemical to electrical, electrical to light, but it's never lost. That's the law of conservation of energy. So, where does power come in? Power tells us how fast work is done. Power equals work divided by time. If you and your friend both carry the same box upstairs, but you do it faster, then congratulations, you're more powerful. Power is measured in watts. 1 watt means 1 joule of work done every second. That's why light bulbs say 60 watts or 100 watts. It's how much energy they use per second to shine. So in summary, work is what happens when a force moves something, energy is what makes the movement possible, and power is how quickly it all happens. From your heartbeat to rocket launches, every bit of motion and change around you starts with work, power, and energy.